welcome back. So in this video I want to introduce the CMode behavior of a cell, the mode in which we actually modify or read a cell's configuration memory. So remember, this is your basic version of a cell, a four-sided block with an input and an output on each side. And we label these north, south, west, east. And our truth table contains four combinations for our data inputs: north, south, west, east. And for each of those we define the outputs of our data lines. So again, 16 combinations. So 16 rows and 4 bits. Specifying with these 64 bits over here exactly what the cell should map inputs into on its outputs. So we need a way to load this bit pattern, the 64-bit pattern, into the cell's memory. So we have an additional set of lines, so I'm going to call these D, inputs and outputs. And there is a second set of lines on each side, which we'll label C. And these C outputs appear in our truth table as well. So we have 4 more columns of output bits. A total of 8 outputs in each row. So for any combination of D inputs, we specify 4 D outputs and 4 C outputs. So this bit pattern that we need to specify the behavior of a cell is now a 16 by 8, which is a 128-bit number. So our truth table is now 128 bits. And we have this added feature that we can specify not only D outputs but also C outputs. But it's still only the D inputs that are used to choose a row in this truth table. The C inputs do something very different. So if all of your C inputs are 0, we call that D mode. So D mode is a state where all of the C inputs are 0. And in D mode, we're just mapping inputs to outputs. The 4 D inputs, pick a row in the truth table, we find the 8 output bits, and we send those to the 8 outputs, 2 on each side, using lookup table as a map from that input combination to the outputs. That's the mode we've been talking about. Different things happen if you have a C input that's equal to 1, though. So if a C input is 1, then we say the cell is in C mode or control mode. So here's what happens. Suppose this C input is set equal to 1. All right, a few things happen. 1, all of the C outputs go to 0. So this truth table is ignored. All of your C outputs are 0. 2, all of these D outputs on other sides are also set to 0. 3, the D output on this side is set to the first bit of the truth table. And at the same time, the D input that's coming in is used to pick a new value for the first bit of the truth table. So there's a single global signal in this whole system. That's the system clock. And the system clock is constantly ticking, and it's normally ignored except when a cell is in C mode. When a cell is in C mode, the first bit of the truth table is sent out the D output on whatever side the C input is being asserted. On the rising edge of the clock, the D input on that same side, we call this the active side, the D input on the active side is sampled and latched internally. And on the falling edge, that latched bit is written into this first bit of the truth table, and the cell now takes the second bit of the truth table and sends that to the D output. All right, so let's go through that again. When a cell goes into C mode, this is called the active side. Non-active sides, D and C outputs are set to 0. Active side, the C output is set to 0. The D input is sampled on the rising edge of the system clock, and on the falling edge, that sampled input overwrites the first bit of the truth table, and the second bit of the truth table appears on the D output. The next time the clock rises, the D input is sampled, and when the clock falls, that sampled bit is written into the second bit of the truth table, and the third bit is sent to the D output. And every time the clock ticks, a new bit is sampled, and every time the clock drops, that sampled bit is written into the next bit of the truth table, and the next bit after that appears on the D output. Alright, what does this mean? It means that from outside a cell, we can set a C input to 1, and by sampling the D output each time the clock ticks, we can read the bits of the cell's truth table. It also means that if we put values on the D input prior to the rising edge of the clock, we can populate a cell's truth table by specifying which bits we want to write into this. Now there's a lot of details that go into this. We need to understand an ordering of the truth table bits. We need to understand the synchronization of the clock. We need to make sure that we know where the system clock is when we put a cell in C mode. And we need to deal with a lot of other details. What happens if we have 2 or more C inputs coming into a cell being asserted, and details like that. But from a high level, this is the basic C mode behavior of a cell. Take bits on the D input, load those into the truth table, take old truth table bits that are going to be overwritten, and send those out the D output on the active side. And by properly manipulating D inputs and outputs on an active side of a cell, we can read, modify, and rewrite the cell's truth table. So the next video, we'll look at that in some detail. We'll see how we can non-destructively read a configuration memory from a cell and use that read information to make a copy of a cell nearby. And then we'll go on from there and see some more sophisticated C mode operations.